Good morning, Doctor. We are Group 10, and today we are going to present the assignment 1 of algorithm analysis, which is the quicksort algorithm.
My name is Mohammad Izzat bin Adnan. I want to present about the introduction and the basic concept for quicksort. Quicksort is an algorithm used to quickly sort items within an array no matter how big the array is. Benefits for the quicksort. The first one is it is quite scalable and works relatively well for small and large data sets. Then easy to implement with little time complexity. Using a divide and conquer method that divide a single large array into the smaller ones and repeat the process until the sorting is complete. Then the steps how the quicksort works. First, a pivot point is chosen from an array. Then the array is reordered so that all values smaller than the pivot are moved before it, and all larger than the pivot are moved after it. With a value equaling a pivot going either way, when this is done, the pivot is in its final position. Then the above step is repeated for each subarray of a smaller values as well as done separately for a subarray with greater values. This is repeated until the entire array is sorted.
Now I want to show how to sort the cards using quicksort based on the attack stats. First step is you must choose pivots. Any from these cards. I want to choose 45. Become first pivot. On the right side, we put more than 45. On the left side, we put below 45 or same number. Okay, 71, 70, 67, 60, 56, 45, 41, 24, 17. We put aside for this one on the right side. As long as there's a card on the left side, we must continue the process. Okay, same thing. A pivot. 24, 41, 55. If there are no other cards on the left side, this become our first cards on the top. Put over here. We're gonna sort it. Gonna check first. Okay, it's already sort. Gonna put all together. Put side. This is already sorted. 45 because our last number is 45. Okay, new pivot. 60, 67, 70, and 71. Okay, all the cards are already sorted. Now we put all together. We're gonna show the output of the cards. 60, 67, 70, and 71. Twenty-four, 41, 45, 56, 60, 67, and the last one is 71. All this card is already sorted by using a quick sort. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Intan Farra Liyanna Binti Suhaimi and I am from 2 BITS S1G1. I will continue the presentation by presenting the picture diagram of quicksort algorithm. As you can see now on the screen, there is an unsorted array that need to be sorted using the quicksort algorithm. So we need to sort the array in an ascending order using the quicksort algorithm. First step in using quicksort algorithm is we need to choose a number to be a pivot. In this example, I will choose number 4 to be the pivot. After choose a pivot, we need to divide the number by move the lower number than the pivot to the right side of pivot and higher number than the pivot to the left side of the pivot. So we put 4 in the middle, and at the right side, we put the lower number, which is -4, 2, -9, and 1. Next, in the right side, we put the higher number, which is 10, 7, 5, and 8. As you can see, the numbers in the right and left side are yet to be sorted. So, to sort the numbers on the right and left side, we need to choose a new pivot from each side. In the right side, we choose number 1 to be the pivot, and left side, we choose number 8 to be the pivot. So we put 4 in the center and we settle the right side first. On the right side, we put number 1 in the middle and divide the number by move the lower to the right side and higher to the left side. So on the right side, we have number that lower than 1, which is -4 and -9. On the left side, we have the higher number than 1, which is 2. On the left side, we choose 8 as the pivot and put 8 in the middle. Then we divide the numbers by move the lower number than 8, which is 7 and 5 on the right side of number 8, and move the higher number than 8, which is 10 on the left side. So now you can see that some numbers such as number 1, 2, 4, 8, and 10 are already in the correct position. But for number -4, -9, 7, and 5, the numbers are not in correct position. To move the numbers to the correct position, we need to choose a new pivot again. So on the right side, we need to choose new pivot between -4 and -9. And on the left side, we need to choose new pivot between 7 and 5. But first, we need to put number 1, 2, 4, 8, and 10 in their position. Then we choose -9 and 5 as the new pivot for each side. Then we put the number 1, 2, 4, 8, and 10 in their position again. Now on the right side, since -4 is higher than -9, so we need to put -4 on the left side of -9. On the left side, since 7 is higher than 5, we need to put 7 on the left side of 5. As you can see now, all numbers are sorted in ascending order. So the final answer and sorted list is -9, -4, 1, 2, 4, 5, 7, 8, and 10. I think that's all from me for the explanation of picture diagram of quicksort algorithm. I will pass the presentation to the next members. Thank you.
Good morning, doctor. My name is Wei Ming, and my matric number is B0320100060. Today, I'm going to taking part in the part 3 to present the part 3 of our assignment 1 for group 10, and which is the part to present and explain the algorithm of quicksort algorithm. Now, the quicksort algorithm consists of three main functions, which is sort function, partition function, and also quicksort function. The first function is the sort function, as you can see. And then what does this swap function do is it takes in two arguments, which is the pointer of A and B, then to swap the two values. The second function is the partition function. The partition function takes in three arguments, which is the array, the lowest position of the array, which commonly is 0, and then the highest position of the array, which is normally the last position of the array. So the first line is to make the rightmost element of the array be the pivot. First, we need to declare the I equals to lowest position minus 1 to act as the position for the first element. Inside the for loop, the array element at position j is being compared to the pivot. And if it is smaller or equal to the pivot, the I will plus 1, and then we will swap the element at position I with the element at position j. And of course, if the first element is smaller than the pivot, the I plus plus and becomes 0, and then they will just won't swap because it is the first element swap with the first element. And then it will swapping and swap, and then after the for loop, we will take the array at position I plus 1, swap with the pivot, which is array at position at highest position. This is to make the pivot to act as a separator, which the left side of the pivot is smaller than the pivot, and then the element at the right side of the pivot is greater than the pivot, and then we will return the positioning of I plus 1, which is the position of the pivot. And then for the last function, which is the quicksort function. Now the quicksort function has in three arguments, which is the array, the lowest position, and the highest position. As quicksort is a recursive function, it will call the partition function again inside. And then you can see there is a quicksort function inside of the quicksort function. So this is what we call the recursive function. And then for the first quicksort function, which takes an array of ARR, low, and PI minus 1, which is the positioning of the pivot returned by the partition function. This is to sort the element at the left side of the pivot by using the partition function again. And then for the second quicksort function, inside of the quicksort function, which is the quicksort with the argument of ARR, PI plus 1, and high. This is to sort the element at the right side of the pivot. Currently, I have a simple program that shows the quicksort functions. So of course, I have all the functions that are needed for the quicksort function, the three functions which are the swap function, the partition function, and the quicksort function. So inside the main, I will declare an array of 5 elements, which over here with elements of 17, 2, 5, 376, and 2 in random order. And then I will show the element first, and then I'll run the quicksort function. After the quicksort, I will print out the element inside the array again. So let's see it. See? This is the random array, and then this is the sorted array after using this quicksort algorithm. So now we'll move on to part 4, which is to explain the complexity of the quicksort algorithm. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Hajar Binti Shaufi. Okay, I will present about the complexity of quicksort algorithm. Okay, as you can see on the left hand side, there is a table. Okay, in this table there is the full coding for the quicksort, and the cost and a column for cost and time. Okay, to calculate the growth rate function, we will add the multiplication of cost and time. Okay, as you can see on the right hand side. Okay, here we multiply the cost and time. So for the C1, C2, C3, C4, and C5, we will multiply it by 1. Okay, for the C6, we multiply by n. And for the C7, we will multiply n times n minus 1. The same goes for the C8 and C9. For the C10, we will multiply by n times n plus 1 here. And for the C11, C12 and C13, we will multiply by 1. For the C14, we will multiply by n times n minus 1. For the C15, we will multiply by n times n plus 1. Okay, for the second equation, I simplify it for easier to view. So I remove the asterisk and bracket, as you can see here. And for the third equation, I factorize it. C1, C2, C3, C4, C5, C11, C12, and C13, all of these are multiplied by 1. So I factorize it and put it in a bracket. Okay, for the C6, it is multiplied by n. For the C7, C8, C9, C10, C14, and C12, C15, it is multiplied by n power of 2. Okay, for this last equation, here I substitute the cost number with an alphabet. Okay, A here refer to C7 plus C8 plus C9 plus C10 plus C14 plus C15. B here refer to C6, while C here refer to C1, C2, C3, C4, C5, C11, C12, and C13. Okay, to know the worst growth rate function, we will remove all the lower level BO notation, which is n and constant. So it will leave only with the n2, n's power of 2. So the conclusion can we get from this complexity is the worst case scenario growth rate function for quick sort algorithm is O n square. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rafiq Mohammad, so I would like to cover the part 5, which is I would like to propose the merge sort is better than the algorithm that our group is choose, which is sort algorithm. So the proof that merge sort is better than the quicksort algorithm is that merge sort is work well on any type of data size, either large or small, while the quicksort only works well on the smaller data sets. After that, merge sort is more efficient and work faster than quicksort in case of larger data set. Merge sort is more stable than the quicksort, which is when input two equal value elements that appear in the same order in sorted output. While under the same scenario, quicksort is unstable. It is stable by using some changes in the coding. Other than that, the complexity of worst case and average case for the merge sort is same, which is big O and log n, while the complexity of worst case of quicksort it is big O and O of 2, which is lower than the merge sort big O relation. As for the speed, merge sort it has a constant speed on any size of data, while quicksort only faster on small data size than the other sorting algorithm. For the sorting method, merge sort is external sorting method, which the data that is to be sorted cannot be accommodated in the memory and needed auxiliary memory for the sorting. While the quicksort is internal sorting method, where the data is sorted in the main memory. So that's all the proof that I can show you. So that's all from me. Thank you.